Hi, this is Ian Ferguson, the VP of Marketing for Lynx Software Technologies. Recently, I had the chance to interview the CEO of a company called Dedalian. Dedalian is a company that is using neural networks to control flying cars. And as part of that interview, Luc van Dijk, the CEO of that company, explained what foundational software building blocks they need in order to run their software.
Last week, we published a report together with EASA on steps towards certifying neural networks for aviation use. And the crux is that many of the things you do by hand when you design an algorithm, if you let the computer in a meta algorithm in the lab design another algorithm, a lot of the assurance goes into the data you use to drive these processes. So we wrote a 136-page report. It's really a PhD thesis worth of information as far as I'm concerned. There's some very deep math in there. So with that, we can make statements about the safety of the emergent properties of the neural network as it looks at the picture and decides that this runway is landable or not. So that's great. So that's the top layer. Now we go one layer down and we're trying to run this neural network on this fancy hardware. And we can use, relatively modern Intels or multi-core ARMs or whatever. And then you see that a lot of the platforms and operating system support out there is really focused on this traditional aerospace. I have my 3 8-bit computers and they must not run out of memory and they must complete their real-time loop 400 times per second. But I have, as a human, I correct the course of my plane once per second. So I believe that the low-level control of the plane, that's been solved by the flight computer doing a 400 hertz or the 100 hertz control loop. I need to go now look at the picture and decide to tell that lower-level system to go there or there. So what I want from my operating system is to get out of the way, basically. So this is actually, I realize I'm talking to Lynx. One of the things we like about Lynx is it doesn't solve problems I don't need solved and that come with a lot of baggage. So a lot of the operating systems want to solve the portability problem. If I write it once, I shouldn't change too much if I want to run it somewhere else. I would already be happy if I had one certified hardware platform that I can run on. If I had two, sheer luxury, I'll worry about that later. So I'm going to have my first one chip. I'm going to really make sure I know that thing inside out. And then I don't want some abstraction layer that sits between me and my bare metal trying to make something easy for me that is not my problem. So what I want from my operating system is that it doesn't sit between me and the metal. So it gives me my partitions, it helps me satisfying the cast 32A constraints, and then I have all my cores running my loops. So there's another problem I don't really have is partitioning myself against other code that's running on the same hardware. So if you give me a 12-core machine, I'll gladly use up all the cores. And if you want to run something else, why don't you go do that on another PCB over there? Having to protect my software against some other process running around trying to access my memory, not an issue. So I don't want the baggage to have to deal with that and then try to work around it. I want a clean operating system.